Hello my dear students, I am B.S. Pandey here with your physics lecture. Today we are in first lecture of another topic. It is kinematics, the beautiful branch of physics. We will study about the motion of particle and bodies without knowing the cause. Alright, we have to study only about the motion. Here the kinematics we are going to start. Today we will be in lecture number 19. It is our lecture number 19. Okay, kinematics. Here, kinematics student, you will find this particular topic in your NCERT chapter number 3, named as the motion in a straight line. It will be written motion in straight line. As the time will go, you will find that the few topic you have covered already in your standard 9th. Okay, my dear students. So here we go. Actually, motion in one dimension we used to study here in this topic, that is the 1D motion, one-dimensional motion. What does it mean by the one-dimensional motion, my student? One-dimensional motion, it means the particle changes position using only one coordinate axis out of three, x, y and z axis. Particle changes position only along one coordinate axis at a time. If the particle changes position using more than one axis, then it becomes two-dimensional motion. That we will study, we will cover that. You have to study in chapter number 4. All right. Now, in this particular segment, we will start with the distance and displacement. Okay, this is the first topic, distance and displacement. Okay, my dear student, here the distance we talk about, the distance we have studied in standard 9, it is the total path length covered. Total path length. Okay, and this is scalar quantity. We don't require any direction. We know that between 2 points there will be number of distance. If you are going directly from this point to this point, this is also distance. If you are moving from here and then finally you reach to this point, this is also distance. Or you are moving back and after moving the last distance or the last path, you are coming again to this point, this is also distance. So distance is the total path length covered by any particle, and this is scalar quantity. It does not require any specific direction for its representation. All right, but when we talk about the displacement, we know that it is the shortest path length. All right, shortest path length. But it is quite obvious, this is also the path length and this is also the path length. It means both are having the same SI unit and it is meter. But this is vector quantity. Alright, this is a vector quantity. It means we need magnitude as well as direction for its representation. It means the quantity having the displacement will be only 1 and 1 between 2 points, because it has a specific direction. Of course, if we are choosing 2 points here, the 2 points, this one, then the shortest length will be this one, and this will be the specific direction. You cannot have the direction if you move little bit at some angle and goes to this point. This will be not the shortest one, and that's why this is the distance but not the displacement. The displacement only will be in a straight line directly from one point to another point. This is the distance and displacement. Okay, my dear students, if we'll see an example, okay, the very simple example, it is mentioned in our NCERT book. Suppose this is the point A and the point B. A boy start moving directly from A to B using this path 1. Another path he chosen to move from A to B is this one, the path 2, and another path it is this one as 3. Although I have been given here the arrow to represent, yes, the particle is moving in this direction, and using this path. But now the question, which path representing distance and which path representing displacement? So we'll reach to the answer, the distance and displacement, path 1, 2 and 3, 1, 2 and 3, all these 3 paths are representing the distance. Okay, whereas path 1 only this path 1 is representing the displacement. I hope you got the answer before my explanation. Okay, so this is the distance and displacement. Let me do some question, a very easy question which is based on distance and displacement, my dear students. You will feel that the questions I am dealing here you have almost already studied in standard 9th. The first question. Here meter scale, or you can say the 3 points A, B and C. A particle moving, this is the scaling 0 meter, 10 meter and it is, or you can say the 20 meter. A particle moving from this within this 3 points, you have to find distance and displacement. Okay, how the particle is moving, I'm giving you the situation, but the question it is find distance and displacement. Okay, first one, A, if particle moving from A to C. All right, the particle moving from A to C, like this way. You have to find from A to C on this straight line going. Remember, don't think that this red one is representing the path. Actually, I'm giving you the true point. Particle moving from A to, let make that this one. Particle moving from A to C. Okay, and you have to find distance and displacement. Remember, while representing the displacement, you must represent the direction as well. All right, here this is the x-axis, our x-axis. Okay, yes. Now the distance from A to C, the total path length, it is 20 meter. So the distance will be 20 meter. Answer, nothing much. Now the displacement. The displacement is the shortest path length will be, again it is the 20 meter, but the direction we are going, or the particle is going from A to B in this direction, and it is I cap. So the answer will be 20 meter I cap. Okay, I think it is signing here. Let me write here the answer. The displacement, it is 20 meter I cap. All right, yes, 20 meter I cap. Now the second question. You have to find the distance and displacement if the particle moving from A to B from C. A to B via C, or from C, you can say. The particle is moving from A to B, but by C. How? The particle goes A to first C and then come back to B. That is A to B from C. What will be the distance and displacement? Here we go. Distance. The particle moved from A to C, it covered 20 meter, then back C to B. The total path length, it is 10 meter added. So the 10 and plus 20, it is 30 meter. We know that we don't need any direction. So it is 30 meter only, the answer. Now the displacement. It is the shortest path length. The initial point, it was O, and the final it is B. So O to B, this one is the direction, and the shortest path length it is 10 meter. So the answer will be 10 meter direction I cap. I hope you understand. The last one I'm giving you, and this will be your homework. You have to find B to B from A. Okay, your homework, it is B to B. Your homework, it is B to B from A. What will be the distance and displacement? B to B from A. Okay. Oh, let me write by the black. It is signing. B to B from A. All right. B to B from A. This is your homework. Now, we move towards another question, another type of question here. Another type of question. On a circular track, you have to find distance and displacement. Okay. Yes. Here, Monty moving on a circular track. This is the circular track. A, B, C and D. Alright. The radius of circular track is R, which is 1 meter. And this is the center, alright, of this circular track. Now the question. On this circular track, if Monty moving in this direction, okay, in this way, clockwise, you have to find distance and displacement. Again, you can write here the direction. It is X axis. And Y axis, it is in plane. All right. Yes. The first one, you have to find distance and displacement A to C. A to C. Okay. A to C. If Monty goes from A to B, then C, you have to find distance and displacement. It's quite easy. The distance you will write here. It goes half the circumference, and it is 2 pi r over 2. That is the pi r, and pi r, it is 1 meter. So the pi radian answer, all right, it is 3.14, that is the 22/7, 3.14 meter. Now the displacement, okay, displacement, it is going from A to C, but the shortest path length between A and C, it is the diameter of this circle, that is 2 meter. So it will be 2 meter. Initial point A, final point C. So the direction will be I cap. Am I right? Yes. Now the next one. You have to find distance and displacement A to D. A to D. Okay. It means Monty goes in this way. Start from A to D. Here. You have to find distance and displacement. Of course, you can find, my dear students. I know that it's not very difficult. Here, second one, A to D. A to D. You have to find distance and displacement. So the distance, it is nothing but the 3/4. It is the 1, 2, 3. Okay, 3/4 of 2 pi r. 2 pi r. All right. The value of r you will put here, the 1 meter. This is the answer, 3/4 of 2 pi r. Now the displacement, it is in meter. Now the displacement. So you can see, my dear students, the shortest path length between A and D, it is this one. Okay, and to find this one, you need to use Pythagoras theorem. This one is the 1 meter. This is also 1 meter, and at a 90 degree, so it is root under 2. So the displacement will be root under 2. Now the direction, in which direction? So you can see it is going, since both the length are same, it means this will be the square, this will be the square, and if you put the axis, you will see it is moving in this direction, that is 45 degree with x-axis minus 45 degree. Direction will be minus 45 degree with x-axis. You can write the direction, or you can write east, west, north, south using this particular direction. All right, now the next one. Okay, on this question I'm giving you another homework, your second homework, which is based, yes, the second homework, which is based on this one. You have to find the distance and displacement A to A then B. Okay, A to A then B, A to A then B. What does it mean? A to A then B. Monty complete one rotation A to A and then it cover another motion, it is B. Okay, this is the extra displacement. You have to find distance and displacement. That is the one complete rotation and then goes to B. You have to find distance and displacement. Okay, my dear students. So you have to solve distance and displacement in this way. A to A then B. Okay, let me wrap this one. Now let me solve few more type of question. Before that, I'm giving you another homework and it is mentioned in SC Burma. Okay, this is question mentioned in SC Burma. You will find, look, it is a carom board. This is a homework. I'm explaining the question. You have to solve by yourself. This is the carom board. This is the question of SCB. Question number 8 you can find if you're having volume 1 of any year, because this book was published in 92 and it has been not edited yet. Now this is a carom board of dimension 4 feet square. All right, we used to put queen at the center. A queen is placed at the center of this carom board. This is the queen, red color. Okay, one striker strike this queen. This is the striker bar. We place a striker here and strike the queen so that this queen moves and rebound, okay, and goes to the post. This is the goal. It goes into the goal post. All right, let me write here the point O. This is the point A and this goal post is the point B. Now the question, it is given in a Burma. You have to find magnitude of displacement of queen. Okay, magnitude of displacement of queen from first one, from O to A. O to A. Okay, that is from center to the front edge, O to A. You have to find the magnitude of the displacement from O to A. Second, you have to find from A to B. From A to B. From A to B. What will be the magnitude of displacement from A to B? Now, third one, from O to B. From O to B. From O to B. This is a question. Okay, I have been explained without using any helping material, helping book. You need to solve this question. This question basically based on mathematics. Okay, you have to find the distance and displacement. This is not very tough question of physics. Okay, now let me wrap this one. Another type of question, my dear student. Here, one very famous question you have faced in standard 9th of drunkard problem. Okay, a drunkard moves 2 steps forward and 1 steps backward. 2 steps forward and 1 steps backward. Okay, Mr. Drunkard. Yeah, beautiful drunkard. Okay, yes, here there's a ditch. There's a ditch on the road. Drunkard, of course, moving on a straight line, Okay, although he is drunk, but moving on a straight line. Are the 2 steps forward? Okay, 2 steps forward and 1 step backward. All right, 2 steps forward and 1 step backward. In this way he is moving, and finally fall into the ditch. From his starting point, suppose it is O, the ditch is 6 meter away. It is the 6 meter. All right, the condition is given: drunkard taking proper steps of 1 step equivalent to 1 meter and taking in 1 second. Okay, is very calculated drunkard, moving 1 step for 1 meter and in 1 second. The measurement of his 1 step, it is mentioned. Now the question: if this drunkard moving 2 steps forward, 1 step backward, and from starting point, if a ditch is there 6 meter away, then you have to find after how many steps drunkard fall into the ditch. Okay, after how many steps? The first question, you have to find out how many steps. How many steps he is having the life before falling into the ditch. And the second question, you have to find distance and displacement. Okay, distance and displacement. And the third, you have to show on the graph, draw the graph of distance. Suppose it is scalar quantity versus time, and displacement, it is a vector quantity versus time. You have to draw the 2 graphs, one distance and time, the another one it is the displacement and time. Okay, so you are having all of the question you have been written. I am having this one to solve this question. All right, and this will be your homework to draw the graph. The third question you have to solve by yourself. Even the second and third, only I am helping you to just explain how this drunkard and how it will fall into the ditch and how many steps he will cover. Remember, he is moving 2 steps forward, so the 2 steps, suppose 1 and then 2, the 2 meter. After that he moves backward, so finally 1 meter, again 2 meter, 1 meter, again 2 meter, 1 meter back, again 2 meter, and fall into the ditch. In this way you have to calculate the total steps he took before falling into the ditch. All right, and then you have to draw the graph. This will be your homework, my dear students. I hope you are much happy to solve this question. You will be happy. This is not very tough question, my dear students. This is the third homework you got today in this section, kinematics. Okay, now the next one. Let me rub this one. Now in this section we are going to study here how to find position and direction of motion. Okay, so the position and direction of motion. Position and direction of motion. Position and direction of motion. Okay, my dear student, suppose if I am giving you a equation, what does it mean by the position and direction of motion? It means if any person moving, okay, in this direction along x-axis, you will write I cap, this is the direction, and position from O point, how much distance, suppose it is covered 10 meter. So this gives you along the x-axis, if it is x-axis and y-axis. Okay, so in this way you have to find the position, that is this 10 meter, and the direction, yes, it is moving towards x-axis. You have to just guess. This is the remember the starting of the question that we will study using the differentiation and integration. You must pay here the proper attention. The one example. Suppose I'm writing an equation x is equals to t square plus 1. Okay. This is the position which is the function of time. This is the position which is the function of time. Position which is the function of what? Time. With the time, this position is changing. T square plus 1. With the time, this position is changing, which is t square plus 1. Okay. I think this one is very disturbing. My flash camera of my phone. From next day, I need to find some solution of this one. All right. So t square plus 1. X is equals to t square plus 1. Now my question, you have to find position. Remember, I will ask the position. You have to find position at t equals to 0 second. Okay. T equals to 0 second. And direction of motion. So let me do at t equals to 0 second, that is the initial position. This is called the initial position. Okay, this is called the initial position, particle about to start. So the answer is at t equals to 0, x will be how much? X will be 1 meter. How much? It is 1 meter. Now, so the answer is 1 meter. If you will try to show over the graph, you will find the particle from the origin at this point at 1 meter. All right. Now this particle is moving in which direction? Along the positive x-axis or negative x-axis, or in which direction it is moving? So the direction. Suppose you are putting here the value of t. We know that the time never decreases. Okay, it will increase always. So if you put here the time 1 second, you will find x equals to 2 meter. It means the particle moved towards the positive of 2 meter. If we'll put here the 2, then it will move 5 meter. 2 to the 4, 1, 5. So it moves along the x-axis for the 5 meter. Of course, the particle is moving along the positive x-axis. So the direction is I cap. I hope you understand, my dear student. Yes. Now the next question. In this way, you have to guess for the next one. If the equation is this one, x is equals to t minus 5. X equals to t minus 5. You have to find position and direction of motion. Again, this is the x-axis, this is the origin. Okay. Now, at t equals to 0 second, x0 will be how much? It is minus 5 meter. Very good. Yeah, of course, particle is here, somewhere here, 5 meter towards the left of origin, that is minus 5, you can say. Now the position, it is the position. Now the direction. As you will increase the value of t, the 1 second, it remain minus 4. It means it shifted toward this point. Minus, if you put t as 2, minus 3, and it shifted toward this one. So the answer, it is moving toward I cap again. Okay, I hope you understand, my dear student. Now the third one. Third example. If I'm giving the equation x is equals to 5 minus t. Now, could you find here the position and direction of motion? Okay, so at t equals to 0, this is the x-axis, the origin. At t equals to 0 second, this x will be how much? 5 meter. From origin, it is at 5 meter. As you will increase the time, suppose it is 0. All right, it is 5 meter. If you will put here the 1 second, that is t equals to 1, then you will find here t is equals to 1, and it is how much? 4. Putting 2, you will find it is 3. It means it is moving towards which direction? Yes, negative of the x-axis. So the magnitude, that is the position, is 5 meter when time was 0. and the direction of motion, it is negative of x axis, that is minus I cap we can put. Okay, I hope you understand how to find the position and direction of motion. In this way we will use the number of questions to find the direction. Okay, one homework from this section also. Two homework I'll give you. Yes. Okay, if x is 4 minus t square, all right, if x equals to 4 minus t square, you have to find the position and direction of motion. Position and direction of motion. Okay, and the second question, if root under x is equals to t minus 1, okay, meter. This is 4 minus t square meter. If root under x equals to t minus 1 meter, then you have to find the position at which time, at t equals to 0, the position, and also you have to find the direction of motion. Okay, my dear students, so this is the first lecture of kinematics. I have not discussed so much questions and very difficult topics, but from next class we will study few very interesting question of kinematics that you have not studied in your standard 9th. Okay, this was introduction class, you can say, of kinematics. Okay, one-dimensional motion. Next class we will study about the motion. It is uniform and non-uniform, and we will learn about the concepts of graph. Okay, my dear students, so this is all about the today's lecture. Thank you very much, my dear students.